Dear students, now we are on the topic of circles objective. IITJEE completed in previous class. Let us going to discuss about circles objective. In previous class, some synopsis we have learnt. Now, 4-5 formulas are there regarding circles objective. Let us discuss synopsis. I think 6 formulas I said in previous class. Synopsis. Now let us start from the formula number 7. Equation of the locus here, the locus of midpoints of chords of circle. The locus of midpoints of chords of circles. Locus of midpoints of chords of circle. X square plus y square is equal to r square. X square plus y square is equal to r square, which are at a distance of k units. Which are at a distance of k units. A distance of k units from center. Which are a distance of k units from center is the locus I am writing as x square plus y square equal to k square. Now let us discuss about the synopsis as a sum. The locus of midpoints of chords of circle. This is M. The M midpoint taken as x1 comma y1, which are at distance of k units from center. This is the center. The circle center is simply 0, 0. So this is k units distance. The locus of chords of circle which are at k units distance from center. So this is k. This is r. So you can write simply Cm is equal to k. So directly you can write as x1 square plus y1 square is equal to k square. By squaring both sides, Cm square equal to k square. Formula number 8 depends upon general tangent of circle. General tangent of circle x square plus y square is equal to r square is x square plus y square is equal to r square is y is equal to mx plus or minus r into root of 1 plus m square. By squaring both sides, you have taken it as quadratic equation of mx minus y whole square is equal to r square into 1 plus m square. So this is of quadratic equation x square minus r square minus m into 2xy minus this is r square plus y square minus r square you can write plus y square minus r square. Plus y square minus r square equal to 2. If this is a quadratic equation in m, if m1 comma m2 are roots of this quadratic equation, we can write the sum of roots m1 plus m2 is equal to 2xy by x square minus r square here. And the product of roots y square minus r square by x square minus r square is equal to product of roots m1 m2. If m1 m2 is equal to minus 1, y square minus r square is equal to minus x square plus r square. If m1 m2 is equal to minus 1, that means the tangents are perpendicular in the circle. General tangents, if two tangents are drawn from px1 comma y1, if the tangents are perpendicular, then m1 m2 is equal to minus 1, then y square minus x square is equal to minus x square plus r square. So it can be written as x square plus y square is equal to 2r square. I think we have learnt example 2, page number before exercise only. Example 1. Maybe page number 56 like that, IP sum. So it is called as a director circle. I think we have discussed the concept of director circle. Director circle is the locus of point of intersection of perpendicular tangents to the circle. Is a concentric circle is known as director circle. The locus of points of intersection of perpendicular tangent drawn from an external point is a circle which is concentric circle is known as director circle. Already we have learned. This is a formula. If x minus h whole square plus y minus k whole square equal to r1 square a circle and x minus h whole square plus y minus k whole square equal to r2 square is another circle, then equation of director circle of the two circles is x minus h whole square plus y minus k whole square equal to 2r square, or here r1 square plus r2 square you can write. I think I said in IPE, so no need to discuss now. Now let us going to discuss about length of tangent. Already we know area of triangle. Eight points completed. Ninth point. Area of quadrilateral formed by the two tangents and the radii. This is IMP level 1. Ninth point. Area of quadrilateral. Area of quadrilateral. Let us draw the diagram like this. Put here Px1 comma y1. Put here Px1 comma y1. And whatever the x1 comma y1 point is there, here you can consider it is the center C. Let us consider this one A point. This is a point of contact and B is a point of contact. This we can understand that this is radius. Radii are equal in any circle. Whenever radii are equal in any circle, then we can understand that area of quadrilateral is r into root s11. Already we have learnt the proof. This area of quadrilateral PACB I am writing. Area of quadrilateral PACB is equal to, we have taken here this one as root S11 and this one as root S11. This is R and this is R. This is right angle triangle. We know that 1 by 2 into R into root S11 and 1 by 2 into R into root S11. 1 by 2 into R into root S1 plus 1 by 2 into R into root S11. So whenever 1 by 2 into R into root S1 we have taken, simply 1 by 2 plus 1 by 2. Directly we can write R into root S1. R into root S1. Next, in the similar way, 10th formula, this is 9th formula. In the similar way, 10th formula, we can say that the length of chord of contact. The length of chord of contact of a point, length of chord of contact of a point Px1 comma y1 with respect to circle. With respect to circle s equal to 0 is 2r into root of s11 by s11 plus r square. 2r into root of s11 by s11 plus r square depends upon this one. Area of quadrilateral, area of triangle is also there. Area of triangle formed by chord of contact and tangents. Area of quadrilateral formed by chord of contact comma tangents is equal to, we have discussed here, r into s11 power 3 by 2 whole by s11 plus r square. IPE sum. Example 5, page number 55 I think. Page 55, example 4, you see the two formulas. Now, let us going to discuss about shortest distance and longest distance. The concept of shortest distance and longest distance. If Px1 comma y1 is any point in the plane of the circle subjective. Twelfth formula, if P x1 comma y1, if P x1 comma y1 is any point in the plane of the circle, then Cp minus R is called as minimum distance or shortest distance. Minimum or shortest or least. Minimum distance or shortest distance or least distance. Comma Cp plus R. What is C? Center. P means the given point x1 comma y1 and R is the radius. Cp plus R is called as maximum distance. Maximum distance or longest. Maximum or longest or greatest. Cp plus R is called as maximum distance or longest or greatest distance. Of circle S equal to 0 to a point Px1 comma y1. If Px1 comma y1 is here, example, this is C, this is Q, this is R. So full this is Cp and R. If we add, that is maximum distance. And if it is Cp plus R, Cp plus R is max, and in the concept Cp minus R is a small value. So using this one, we know that I am writing Cp minus R into Cp plus R. Cp minus R into Cp plus R can be written as Cp square minus R square. Power of point definition, I said that power of point with respect to a circle is simply nothing but it is Cp square minus R square. Cp square minus R square is equal to S11. Therefore, we can say that lengths of shortest comma power of point comma lengths of shortest comma power of point comma longest distance. Lengths of shortest comma power of points comma longest distance are always in GP. This is a main point. Are always in GP. That time this is the concept. B square is equal to AC concept. Cp minus R into Cp plus R is equal to S11. So S11 is the power of point and length of shortest and longest, and power of point are GP. Concept is B square is equal to AC model. Next, sum of shortest comma longest distances. Level 1 sum is there. Sum of shortest comma longest. Sum of shortest comma longest distance is equal to Cp minus R plus Cp plus R. So R and R will be getting cancelled. It is 2Cp. So 2Cp, the value is in arithmetic progression with longest and shortest distance. Next, now let us going to discuss about the length of direct common tangent and length of transverse common tangent. Length of direct common tangent and length of transverse common tangent. Put side heading length of, length I am saying to length of direct common, length of direct comma transverse, both we can do. Length of direct comma transverse common tangents, direct comma transverse common tangents. Let us discuss about the direct first, transverse later. First one, direct common tangent. Length of direct common tangent. Let us draw the diagrams of two circles like this. Students, this is the direct common tangent. Already we have learnt about common tangents concept. Direct common tangent. Put here, this is C1. This is C2. Draw like this, it is better. C1. Draw like this. Draw like this. We know that the line joining centers C1, C2 can be indicated with the letter D. D means distance of line joining centers. Let this is P point and this is Q point, point of contact of direct common tangent to first circle S is equal to 0 is P and the second circle S dash is equal to 0 is Q. Now we can say that this one, this is R1 because from center to any point on the circle is called as radius. This is R2. From center is any point on the circle is called as radius. Whatever this part is taken from R1, this part becomes R1 minus R2. You can write here this is R1 minus R2. We know that this is right angle triangle because it is a diameter. Whenever C1P extended until here, it becomes diameter. Every diameter divide the circle into two equal parts. The parts are said to be semicircle. We know that angle in semicircle is 90 degrees. Now, let us draw this one once again. Draw this one once again. Students, this is nothing but D. Because D I have drawn parallel. P put here R. So, this is RQ you write. RQ. RQ you have to tell. This is P. P is R1 minus R2. P is R1 minus R2. Here it is 90 degrees. In the right angle triangle, this is hypotenuse. Whatever the opposite side of right angle is hypotenuse, hypotenuse is D here. This is R1 minus R2. Now we can write in right triangle PQR. Here D square is equal to, because D square is hypotenuse square. D square is equal to PQ square plus PR square. PQ square plus PR square you can write as R1 minus R2 whole square. PR square you can write this one as R1 minus R2 whole square. That implies PQ is nothing but length of direct common tangent. PQ is equal to length of DCT I am writing. length of dct. Length of dct is equal to, taken this one, this r1 minus r2, left side it becomes d square minus r1 minus r2 whole square. This one, d square minus r1 minus r2 whole square is the length of direct common tangent. Students, don't forget it. Length of dct. This is useful. In mains also he given. Of course, it is not in advanced. For MSET it is okay, but in mains also he asked the question. Not proof, students. He did not ask about proof, but some will be given in the way that C1 he used to give, C2 he will give. Whenever C1, C2 given, then you can calculate easily regarding distance between 2 points. Later R1 also will be given, then you can say directly d square minus r1 minus r2 whole square over root is equal to direct common tangent. Now let us going to discuss about length of transverse common tangent. Length of transverse common tangent. This is the 14th synopsis. I think this is 13th synopsis. Letter 14. Lengths of transverse common tangent. Length of transverse common tangent. Let us draw the diagram like this. Better to draw. This is the transverse common tangent. Put here C1. Put here C2. Draw like this. This one. We know that C1, C2 is equal to D. Now we should calculate, students. This is R1. This is R1. This is R2. We can do one thing. If we extend this length until R2, if we extend the same distance R2, then it becomes here R1 plus R2 the distance. Draw like this. The same distance we have extended here. The same distances. Put here it is a point of contact P and this is a point of contact Q. This one extended R. Here this is right angle and this is right angle. So this one also you can say it is right angle. This is C1R. C1R you can say that it is R1 plus R2. Radii, sum of radii here R1 plus R2. We know that the PQ is the distance between the points of contact. The distance between the point of contact PQ is nothing but the length of transverse common tangent. Whenever length of transverse common tangent is there, we have extended until R2 here, so this becomes D2. Now we can consider the triangle CRC2. Consider like this. CRC2. Here C1. C1, this is R and this is C2. Now we should calculate the PQ. So RC2 became D, otherwise PQ became D. PQ parallel to RC2, it is D. Now C1R is R1 plus R2. C1R is R1 plus R2. So C1, C2 is D. Don't think this one D. Why? Because put another name. Simply leave it. Otherwise put X. Put X. So now using this triangle, in triangle C1R C2, In triangle C1 or C2, we can say here x square plus r1 plus r2 whole square. X square plus r1 plus r2 whole square. So x square you write, what is x? Length of TCT. Length of TCT means length of transverse common tangent. X you write. So it becomes over root square root of d square minus r1 plus r2 whole square. Length of common tangent, that too transverse common tangent formula, root of d square minus r1 plus r2 whole square, and length of direct common tangent formula, root of d square minus r minus r2 whole square. Proof is not needed, students, but the sum is needed in MSET and mains also. Now let us going to discuss another point, depends upon the conjugate points. If we draw three polars with respect to given 3 points, if the polars are concurrent, based on the 3 points, then the 3 points are collinear. That I want to discuss with you. 14th question, 14th synopsis. If 3 points P, Q, R are in the plane of circle, whether it is outside or inside or anything, no need to discuss the position. If 3 points P, Q, R in the plane of circle, P, Q, R, 3 points in the plane of circle. If 3 polars of these points, if 3 polars are concurrent, 3 polars are concurrent with respect to a circle, then the point is that P, Q, R are collinear. This is simply synopsis. Let us go into discuss about this concept with the diagram. Put P here. P I have taken. Whenever polar is needed, the points of intersection of tangent drawn at extremities of chord, which is drawn in the plane of the circle, which the point is drawn in the plane of circle, P external point I have taken. Whenever I have taken P external point, we should draw a secant, then it should intersect the circle in 2 distant points. Put here A, B. Draw a tangent using extremities of tangent A and using extremities of A and B. A tangent you have drawn. The locus of points of intersection of this tangent is called as polar of P. And in the similar way, you take another point Q. Here you take another point Q. Whenever a point Q you have taken, simply you take the line this one and draw an tangents extremities of chord. Put here C, D. This is a polar. Draw like this. If here the polars are intersecting here, take another point R here. Then in the similar way, you consider the polar. Whenever you are calculating the polar, you write here, draw tangents of extremities of chord here E and F. Put the names here. Draw the polar of this R. So the polar is also passing the same point. What is happening? It is a concurrent. Whenever the polar of P, polar of Q, polar of R concurrent, then you should try to understand here P, Q, R, this one lie on the same line. Now you can say that here collinear. Students, if we draw plenty of lines, now only we are in the confusing mood. If you are drawing plenty of lines, then you will be in confusing mood. That is why you only have drawn 3 lines, taken 3 lines. That is why you can say that the points of, if points of 3 polars are concurrent, whenever the points of 3 polars are concurrent, then the P, Q, R are collinear. Now, before going to discuss CUQ, let us going to discuss worked example 28 and worked example 29. Synopsis completed, students. Depends upon the exercise. Depends upon the circles. Until mains level we have discussed. Wherever the advanced level is necessary, I will go to discuss with you. Now let us going to discuss about worked example 28 and worked example 29. Worked example 28. If m1 comma mi he given, if mi comma 1 by mi comma 1 by mi comma 1 by mi are 2 points. If mi comma 1 by mi are 2 points with respect to circle, x square plus y square is equal to r square. Of course, he given as distinct points. If mi comma 1 by mi is equal to mi greater than 0, he given, that is for 1, 2, 3, 4. For 4 points, mi he given 1, 2, 3, 4 are 4 points on circle. 4 distinct points. 4 distinct points on the circle. I am considering the circle as x square plus y square is equal to r square. Of course, lengthy circle also we can take lengthy circle also, but x square plus y square equal to r square is easy. Then show that m1 dot m2 dot m3 dot m4. m1 into m2 into m3 equal to m4 equal to 1. Some staff member used to say m1 comma 1 by m1, m2 comma 1 by m2, m3 comma 1 by m3, m4 comma 1 by m4 equal to 1. The points satisfies the property. Now let us going to discuss the circle x square plus y square minus r square equal to 0. Since here he given 4 points, 4 distinct points lie on the circle. This is A, this is B, this is C, this is D. Here you put here m1 comma 1 by m1. At B we can write here m2 comma 1 by m2. At C we can write here m3 comma 1 by m3. At D here you can write m4 comma 1 by m4. These are the 4 points lie on the same circle. That implies if we take this one in generalization as m square plus 1 by m square minus r square equal to 0 you write. That implies m power 4 minus r square m square. m power 4 minus r square m square plus 1 equal to 0. Now we can write this is a biquadratic equation. This is a biquadratic. This is a biquadratic equation. Therefore, m1 comma m2 comma m3 comma m4. m1 comma m2 comma m3 comma m4 are roots. I think you know that for a quadratic equation, sum of roots equal to minus b by a and product of roots equal to c by a. So sum of roots becomes minus negative later plus. For a quadratic equation also, sum first one means m1 plus m2 plus m3 plus m4. It is that means sum of roots taken at a time becomes minus later plus minus plus minus plus like that. The product of roots we can get the answer is plus 1, product of roots. First of all, you simply understand as it is simply C by A model. M1, M2, M3 equal to this is C 1 by 1. That's all. It is equal to 1. So M1, M2, M3, M4 product of roots is equal to 1. It is IMP question for MSET. Let us going to discuss about worked example 29. Worked example 29. A circle is inscribed in an equilateral triangle. A circle is inscribed. A circle is inscribed in an equilateral triangle. Equilateral triangle of side A. Equilateral triangle of side A. Show that the area of the square. The area of square inscribed in the circle. The area of square inscribed. Area of square inscribed in the circle is equal to a square by 6. It is IMP mains question. Depends upon much concept. A circle is inscribed in an equilateral triangle. Let us draw the triangle. In the triangle, a circle is inscribed. Put here names A, B, C. In the circle, a square is inscribed. Let this is a square. Put this is as PQRS. Join like this. This is center C. This is center C. This is capital C. This is small c. From center to any point of the circle is called as radius. This is R. This is R. Let the side of the square be X. We should calculate area of square. Join like this. Put here it is a D. So better to think this is center D and this is E. Description. Let small a be the side of triangle. Small a be the side of equitriangle. We know that H is equal to, that is AE. H is equal to, for an equilateral triangle, H formula root 3 by 2 into A. And for an equilateral triangle, circumcenter, orthocenter, incenter and centroid, 4 are same. So we can say that AE is the median of the altitude. Here AD is the altitude of the triangle. The altitude divides, of course median divides AD, this one in the centroid divides. Here D is centroid. Centroid divides every median in the ratio 2:1. Here I am writing for equitriangle. For equilateral triangle, AD is to DE is equal to 2:1. So AD is to DE is equal to 2:1. Now AE is equal to root 3 by 2A. So DE is equal to, here we can say that DE total 3 parts. So total H, altitude H is equal to 3 parts. So 3 parts is equal to, 3 parts is equal to here root 3 by 2A. Students, this, because this is triangle, until here extend, not here. Until here, put here E. This is better. Put here E. This is A by 2, A by 2. I think no need here A by 2. So AE is equal to, AE total is equal to, total parts H equal to root 3 by 2A, total parts 3 parts equal to root 3 by 2A. One part means DE is from center to any point on the circle is called as radius. So one part is equal to radius. One part is equal to radius dE is equal to R. So one part you needed root 3 by 2. Here I am writing R is equal to root 3a by 2 into 3. So here you can write a by 2 root 3. A by 2 root 3. Now PR is equal to diameter. PR is equal to diameter is equal to 2R. So diameter 2R. Diameter 2R means here simply A by root 3. 2R is equal to A by root 3. Now we know that diagonal of square is equal to x into root 2, side into root 2 of the square, because x square plus x square root 2 x square concept. So you can write here x into root 2. X into root 2 is equal to a by root 3. So x is the side of square. X is, if you are having any doubt, simply write like this. X is equal to side of square. Side of square. So x is equal to a by root 6 you write. Now we need here area of square. Area of square is equal to x square, side into side. So it is a square by 6. It is important, students. A square by 6 is the area of the square which is inscribed in the circle, which is inscribed in the equilateral triangle. So whatever the side he given, the area of square depends upon the square by 6. That's all. If he given x square by 6, if he given p square by 6, this is a formula. Depends upon this formula, sums are there. Otherwise a square by 6 also he may ask. There is a chance to ask this question directly in mains. So remember this one as a formula. Next, last one today. Next, let us going to discuss secant rule. If two lines drawn from a point px1 comma y1 to a circle s equal to 0, if they intersect, the circle, in two distinct points, a comma b and c comma d, draw like this. Here put p, here this is a, this is b, like this. Put c, this is c, this is d. PA dot PB, that implies you write here. Then PA dot PB is equal to S11 in IPE. I said the proof also. If Px1 comma y1 is a point, if A, the point on the circle is R1 unit distance from Px1 comma y1, and B, a point as R2 unit distance from Px1 comma y1. In the similar way, of course, R3 comma R4 you can put using the circle x square plus y square is equal to R square, using parametric equation R square cos theta and R square sin theta. By taking the R square quadratic equation product of which I said that R1 R2 equal to S11, we got the value. We said the proof also. So PA dot PB is equal to S11 and PC dot PD is also S11. So that implies you can say that here PA dot PB is equal to PC dot PD. This is a rule, it is called as secant rule. Secant rule. Now Whatever the synopsis and examples I want to discuss with you, the sums completed. Let us going to discuss in brief manner that CUQ, that is theory bits. Theory bits. After completion of CUQ, level 1 I will not handle students, level 1 classwork, level 1 homework also you do. Level 2 I will handle, level 2 classwork, level 2 homework if any chances are there to handle the sums, whether it is important, the concept is there, I will handle. Otherwise you do the work. Level 3 100% I will say. Now let us go to discuss about CUQ, theory bits. Every student should have material. I will not write the question here after on the board. Number of circuits. First question, number of circuits drawn through 2 points. First question, number of circuits drawn through 2 points. Take this one. This is a P and this is a Q. Depends upon PQ. Draw a circle like this. And draw a circle like this. And draw a circle like this. Like this. Draw a circle like this. So what did you observe? So plenty of circuits we can draw, infinite. That's all. First question answer. Second one, if 3 lines are not concurrent, no 2 of them are parallel, number of circuits drawn touching all the 3 lines. I said the concept 4. It forms a triangle. So second question, second option. Equation of circle passing through non-collinear points A, B, C. Third question he given equation of circle passing through non-collinear points. Third one, equation of circle passing through non-collinear points, like that you should draw. So it is nothing but S plus lambda L equal to 0. For S also I said that equation of circle having endpoints of diameter x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Plus L means the same line y minus y1 equal to y2 minus 1 by x2 minus x1 into x minus x1. So depends upon the S and L, you should calculate another circle in the form of x plus lambda L equal to 0. Depends upon that one, he given the first option, try to understand. Equation of circle on AB as diameter plus K into equation of AB equal to 0, that's all. Next, fourth question. In IPA, set the proof, equation of chord, x plus g cos of alpha plus beta by 2 plus y plus sin of alpha plus beta by 2 is equal to r cos of alpha minus beta by 2. There I said that x plus g into cos of theta 1 plus theta 2 by 2 I said. Y plus f into sin of theta 1 plus theta 2 by 2 is equal to r into cos of theta 1 minus theta 2 by 2. So, fourth question, second option. Now, let us discuss about fifth question. Fifth question, if the circle touches the x-axis at x1 comma 0, if the circle, this circle, x square plus y square plus 2gx, x square plus y square plus 2gx plus 2fy plus c equal to 0 touches the circle at x-axis. You can say g square is equal to c condition. Whatever the conditions I said in IPA, I did not discuss an objective. Apart from IPA, what is needed for objective, that concept only we have discussed. Now x square plus y square plus 2gx plus 2f plus c equal to 0. You can write here x1 square plus 2gx1 plus c equal to 0, because simply put the value x1 comma 0. The locus here written as first option, x square plus 2gx plus c equal to 0. Next, sixth question, geometric mean, he said, just today only I said the concept that cp square minus r square equal to s11. If he is asking geometric mean, you can say it is root of s11. That's all. Mod he given because length is always positive. Second option. Next, seventh question is there. Seventh question, locus of point of intersection of tangents drawn to the circle x square plus y square is equal to a square. Tangents are drawn here including an angle alpha. The answer is x square plus y square is equal to a square cosecant square alpha by 2. You see the IPE question, exercise 1D. IPE question, exercise 1D, page 146, Roman number 2, fourth question. See the question. Next, eighth one. Eighth one, A and B are two fixed points, the locus of such the triangle APAB, sin B by sin A is constant. Here, sin B by sin A is equal to K. So, what is sin B by sin A? We know that A by 2R, B by 2R constant. A and B are fixed point, locus of P such that A and B are fixed points. Locus of P. Put here A and B. Put here P. So this is very, is asking about sin B by sin A. You can say here sin B by sin A means B by 2R by A by 2R. So B is equal to A. B means what is B? Opposite of B. So PA. You can write to understand PA by, what is A? Opposite of A. PA by PB. PA by PB is equal to K. Wherever PA is equal to K, PB is there, locus is called as Apollonius circle. This proof I said in exercise 1A, page number 24, you verify. Locus is called as an Apollonius circle. So according to option, it is circle. Now, let us going to discuss about ninth question. Ninth question. A tangent is a point on the circle. It is IMP question. Draw diagrams. Yes. A tangent at a point on the circle x square plus y square equal to a square. For this one, tangent is there. Put here 1, put here 2. This is 3. A tangent at a point on the circle x square plus y square, a tangent, a point on the circle x square plus y square root a square intersect the concentric circle S at P and Q. Let the second circle is a concentric circle. Whatever the tangent we have drawn, the tangent is intersect the concentric circle P and Q in distinct points P and Q. P, Q. The tangents of this circle at P comma Q meet the circle x square plus y square will be square. This, wherever tangents you are drawing here, this meeting here and this one meets like this. We draw in proper way. Like this, try to understand this one. Center is same. Tangent of this is 1. This is the concentric circle, whatever he given, that S is equal to 0. This is third circle. First circle is that x square plus y square is equal to a square. Let it be first one. Concentric circle. So, observe that thing that x square plus y square to a square, he given x square plus y square to b square, he given outside. The concentric circle for the x square plus y square to a square, for the x square plus y square to b square is let x square plus y square to r square. Concentric circle. Concentric circle, this one you write as x square plus y square is equal to r square. He put the name. This is S equal to 0. Next one. Third circle x square plus y square is equal to b square. So this is px1 comma y1. Think like this. You should try to understand that this is an extremity, this is a tangent drawn at extremity of a chord, this is a P and this is Q. So of course you can say that PQ, this is R input. We should calculate the locus of Rx1 comma y1. Rx1 comma y1 is a point on the circle x square plus y square is equal to b square. Here you write Rx1 comma y1. R x1 comma y1 lie on 3. this is 3. That implies, this is second one, this one we needed, we should calculate. So you substitute here, x1 square plus y1 square is equal to b square. x1 square plus y1 square is equal to b square. If we draw the chord of contact to the circle, x square plus y square equal to r square. This is PQ is nothing but a chord of contact. Chord of contact. Chord of contact of concentric circle x square plus y square equal to r square is formula xx1 plus yy1 minus r square equal to 0. If this chord of contact, this is tangent to that circle, this is tangent to circle x square plus y square is equal to a square. If this is tangent to circle x square plus y square is equal to a square, whenever a line is tangent to a circle, use r is equal to d. What is the center here? 0, 0. What is the radius here? It is a. So you can say that a is equal to A is equal to modulus of minus r square, because mod 0, 0 from 0, 0 to this line, mod c by root of a square plus b square concept, minus r square by x1 square plus y1 square. So you write here a is equal to r square by using this one, x1 square plus y1 square is equal to b square. So simply you write here b. So r square is equal to ab. So what we got the equation as r locus. Locus of x1 comma y1 or concentric circle you write. Concentric circle. Concentric circle equation is x square plus y square is equal to AB. This is the CUQ theory bit you should understand as a formula. This is of course is nothing but synopsis. In Deepthi book used to give as C and D, formula x square plus y square equal to AB. In Arihant book used to give as alpha beta, formula x square plus y square equal to alpha beta. In somewhere in Escham, gamma delta, formula x square plus y square equal to gamma delta, like that. Just simply product the radii. X square plus y square is equal to AB. Let us going to discuss about 10th question. If T1 comma T2 are lengths of tangents. If T1 comma T2 are lengths of tangents. Lengths of tangent drawn from conjugate points A comma B. Draw diagram, rough diagram like this. Put like this. This is P. This is A, this is Q. This length of tangent is T1 and T2. He is giving as this is A, this is P. This is P. If T1 comma T2 drawn from tangents are drawn from two conjugate points A comma B, then T1 square plus T2 square. So what is T1 square plus what is T2 square? T1 is length of tangent. So let circle S is equal to x square plus y square minus r square is equal to 0. Let here a x1 comma y1 and b x2 comma y2. A x1 comma y1 and b x2 comma y2 are conjugate points. A comma b are conjugate points. Whenever a comma b are, if I am writing, if a comma b are conjugate points, the condition is S12 equal to 0. Of course, S12 notation is x1 x2 plus y1 y2 minus r square is equal to 0. Now T1, what is T1? Length of tangent. Now I am writing T1 square plus T2 square. T1 comma T2 are lengths of tangent. Length of tangent formula root S11. Root S11 depends upon x1 comma y1 it is root s11, depends upon x2 comma y2 it is root s22. So you can write here as whenever t1 square plus t2 square he given, you can write this one as x1 square plus y1 square minus r square, like this you write. So you can write here as x1 square plus y1 square plus x2 square plus x2 square plus y2 square minus 2r square is the value of t1 square plus t2 square. Now what is the use? Depends upon the option. We can write now ab square. AB square means it is nothing but a distance between 2 points. You can write here x1 plus x1 minus x2 whole square plus y1 minus y2 whole square. Depends upon the formula. You can write here x1 square plus y1 square. In the similar way you get x1 square plus y1 square plus x2 square plus y2 square minus half 2x1 x2 plus y1 by 2. Whenever you have taken common 2, so it becomes within the brackets you can write as x1 x2 plus y1 by 2. Here from 1 you write here from 1. First equation indicates that x1 x2 plus y1 by 2 is equal to r square. You put here as is equal to r square. So here you can write this one as x1 square plus y1 square plus x2 square plus y2 square minus 2r square. x1 square plus y2 square, x1 square plus y1 square plus x2 square plus y2 square equal to minus 2r square. This one, understand this one and this one. So we can say that t1 square plus t2 square is equal to ab square. Students, depends upon this sum. This theory sums are there in MSET, of course not in mains. But you should remember this one as a formula t1 square plus t2 square is equal to ab square. Sums are there. Okay, we have completed the theory. Let us going to discuss about next theory in next class.